Gomes. Marcelo is also one of the organizers. He's a very busy person, cannot stay all the week, but came anyhow today and tomorrow. And so Marcelo is, well, he is a physicist by training, but he actually now is a researcher in public health, and he works at the Fundação Oswaldo Cruz, Fiocruz, in Rio de Janeiro. And so, that's it.
So, good morning, everyone. As Roberto just said, my name is Marcelo Gomes, public health researcher at Fiocruz, and I'm currently working also as the Coordinator General of the surveillance of COVID-19, influenza, and other respiratory viruses in the Brazilian Ministry of Health within the Department of Infectious Diseases. So the classes that I'm going to give you today and tomorrow morning focus on analytical methods for epidemiological surveillance and focusing, obviously, in the context of respiratory infections, but that can also be applied to other diseases as well. So basically to go over some of the details behind what is actually in the data that we can access for epidemiological modeling, for surveillance, and so on and so forth. So going a little bit under the hood of the data itself and how the particularities of how the data is processed, collected and processed affects our analysis and how we treat that data through our analysis, okay? Because in the other classes that you have in the school, there's a lot of mention to actual mathematical modeling and data fitting, and those details, as I hope will become clear in these three lectures, are absolutely fundamental to how we use the data into our models and how we interpret it. There are a lot of intricacies and pitfalls that if we are not aware of them and we don't look into those details, we might actually come up with results from our methods that actually don't have anything to do with what's actually going on in the epidemiological scenario, okay? So this will be the main focus of what I'll be discussing with you. So let's start our deep dive. Okay. So first of all, when dealing with epidemiological data, some of the main aspects that we want to understand is, well, first of all, what we are looking for, right? So what is the disease or the infection or the pathogen that I'm looking for? Whom? So who are the persons that are being affected by that particular disease or pathogen? When the cases are happening and where, right? So, in terms of what, as I mentioned, we must, of course, first have a clear definition of what is exactly that we are looking for, okay? And we'll go over some of the aspects behind that. For instance, if I'm interested in a specific pathogen, and I want to identify cases that are specifically associated with that pattern, let's say the flu, right? So cases, persons infected with influenza viruses. What will be the criteria that I will use to identify positive cases? Is it just syndromic? Is it laboratory-based? If it's laboratory-based, with which test will I use as my standard? Why is this important? Because those criteria affect the number of cases that I will be counting in the end, right? And in terms of lab tests, different tests have different qualities, have different sensitivity and specificity associated with that test. So depending on my choice, again, the quality of the data, the accuracy of my data will be affected by that. And my ability to also to compare data from different localities, from different regions, it's also impacted, right? Because if I'm using one criteria and another locality is using another, not necessarily those two data sets will be actually comparable, right? Especially in terms of magnitude. They might be, and then they can be comparable in terms of trend, right? Whether cases are increasing or decreasing or stabilized. But in terms of magnitude, probably not, right? In terms of whom, then this is important mostly if I want to characterize, for instance, what are the specific risk groups, right? If, again, taking the example of influenza, in terms of hospitalizations, most of the cases are on the extremes of the age strata, right? Small children and older adults, right? Those are the groups that are mostly affected in terms of hospitalization by influenza. If in the process of collecting data, I don't collect also what is the age, or at least the age strata of the individuals, I will lose that information. And so my ability to identify group risk will be affected if I don't store that particular information. The same might apply for sex at birth, other socioeconomic factors like where specifically, and this also go into the last one, where this individual lives, if this person have underlying health conditions that also might affect its vulnerability to that particular disease, and so on, right? This goes all into the characteristics of the whom, right? When, of course, if I want to be able to identify current scenario and produce frequent alerts related to this particular disease, knowing when the cases are happening, of course, is absolutely fundamental. And there are a lot of details behind the data that impacts a lot my ability to identify clearly when associated to the cases that I'm looking at specific data sets. And where, of course, as I've mentioned, it's important to be able to stratify again by, of course, for instance, even within the same state, the epidemiological scenario in different cities might be completely different, okay? And this, in fact, usually is the case. So being able to identify, and then one of the main balances that we have to take into account as well, how finally detailed I will stratify my data, and how much this will only increase the complexity and lose ability to analysis. So this, if I look into the state as a whole, at the municipality level, within municipality, right? So stratifying by neighborhood. Is this extremely necessary? Well, depends on what is the specific disease that I'm looking at. So a lot of those points that I mentioned here, how deeply I will dive within each of those aspects, most of all, almost always will be extremely connected with the what part of my question, okay? The specific disease will guide how much detail I need within each of those classes. Now, in terms of what, as I've mentioned before, case definition is absolutely central. So again, looking into taking the example of respiratory infections. So in terms of severe acute respiratory infections in Brazil, so severe acute respiratory infection is basically loosely defined hospitalized cases associated with respiratory viruses in general. Okay, so it might be associated with the flu, with SARS-CoV-2, RSV, and several other viruses. So pneumonia can also manifest itself as a SARI case. So an individual that became hospitalized, and the reason for this hospitalization is associated with respiratory symptoms. Generally, this falls under the umbrella of a SARI case, okay? There is a specific case definition. I will not go into the fine details of that, but what I want to focus now is how we have a notification system dedicated to this particular manifestation, okay? So there is a central database that all cases associated with SARI should be inserted in that database. So every hospital in Brazil should, in principle, notify whenever it has a patient that falls under the case definition for SARI, it should notify, should insert into the dedicated database, okay? We have similar situations for arboviruses, for dengue, Zika, chikungunya, and so on, which is not, the notification is not associated with hospitalized cases. Is every mild case. So every outpatient visit associated with dengue should be notified. There is another specific database associated to those cases specifically, and it also has a case definition and so on and so on. Now, the thing is, if I look, can I take all the cases that are notified within that database, or should I look at the within that database those that actually attend the case definition that I have established? Those numbers, those two numbers might not, right? Because it's one thing to have a system put in place for a given disease, and it's another thing to have the person that is doing the actual notification to adhere to the case specification, the case definition that you have established. There is no guarantee that those two things will actually meet always, right? So if we take two approaches here, so in the first approach, I will look at all the cases that have been notified, which has a marker there that guarantees, at least in terms of the database, that the patient has been in fact hospitalized or has become deceased, okay? Because those two are absolutely central in terms of SARI, okay? So SARI is individuals with respiratory symptoms that have been hospitalized or have died because of those those symptoms, even though they might not have been hospitalized before dying. So those are paramount. So one way to look at the data is, well, I will filter out notified cases, looking only whether individuals have in fact been hospitalized or have died because of that particular reason to be notified. And the second approach is, well, I will take the data and I will look at the variables that are available within that data set and apply to that data set the case definition that is established in my surveillance system. Okay, so I will look whether it has been checked out all the necessary conditions that are associated with my case definition. Okay, so for instance, if the individual have presented coughing, if it had either coughing or sore throat, if it had presented any manifestation of difficulty in breathing, those are also a part of the case definition. Now, what happens is now looking into the data set and applying, filtering out, counting the number of cases for every year between 2014 all the way to last year, 2024, what we have here is the relative difference in terms of the number of cases that I have each year for all the cases, all SARI cases, those that have been associated with influenza, with RSV, so respiratory syncytial virus, or SARS-CoV-2, so those associated with COVID-19. And what we see is that, well, for influenza, about I have a difference there of about of the order of 15%. So when I apply the actual case definition, I lose about 15% of all the cases that have been inserted into my database. Now, what happens? What is going on with those 15%? I have absolutely no idea. Now, if what I'm doing with the data, what I'm asking to the data is extremely associated with my case definition, is if I want to guarantee that the analysis that I'm performing is associated with those cases that attends my case definition, those 15%, I cannot count on them because I don't know if they actually attend the case definition. And this might have an impact in the risk group that I identify. It might affect the current scenario that I'm looking at. So there are several aspects that might be affected by that. Okay. So depending on what I'm doing, I must filter out those 15%. For the cases associated with SARS-CoV-2, of the order of 40% didn't meet the criteria established beforehand. For RSV, about 10% more or less. This is for the whole period. Of course, for SARS-CoV-2, this only applies to 2020 onwards, because before that, we didn't have this particular virus. Now, what happens if I restrict my whole data set to 2020 to 2024? What I see is that for influenza, and of course for SARI overall, I also have a greater percentage of cases that do not meet my case definition criteria. So about the order of 35% more or less. And even for RSV, now I'm closer to 20%, right? So it was a little bit below, the median was a little bit below 10%, and for that period alone, it's almost 20%. So this points into the direction. So what happened here? The actual number of cases before 2020 and after 2020 is completely different. It's absolutely different. So in this period, I have much more cases notified than I had previously, because of the impact of SARS-CoV-2 for one, and another key aspect is the actual adherence by the hospitals to the surveillance itself. Those two things are happening there. Now, when we have this process of an increase in the number of hospitals, and at the end of the day, individuals that are actually notifying my cases, the simple magnitude of cases might impact the quality of this task of filling out the whole form. It's one thing to fill out a sheet that have about 80 items to be checked: symptoms, age, previous medical conditions, the localization of the individual, vaccination status, and so on and so on and so on. So now we have about the order of 80 fields that should be checked out. So it's a huge form. And the individuals that are actually performing this task of filling these sheets usually are the same that are actually dedicated to giving care to those patients. And they have to balance the amount of time that they are dedicating to giving care to the patients and the amount of time that they are dedicating to filling out a form. It's a tough choice. Not that tough, actually, right? And this impacts the quality of the data, of the filling out of the form. So for those individuals, for those notified cases, it's very likely that, that a significant percentage of those actually did meet my case definition criteria. It was simply not filled out in the form, that particular information, okay? But again, I cannot guarantee that. So again, depending on what I'm doing with this data, I still should filter out those cases. Unless I go back to the hospital and I check the medical record that is stored in the hospital database, and then check whether, well, if it was only a matter of not filling out the specific notification sheet, or in fact, indeed, the individual did not make the criteria. But this is a huge task, right? Especially if the number of cases is enormous, which is the case here. So it's not feasible at all. Only it might be feasible in retrospective, but as the epidemic is developing, it's not feasible at all. So what I do, again, I have to make a choice here depending on what I want to do with this data set. So, and another important aspect is also why we have this important difference here between what is going on with the cases associated with RSV and those associated with the flu and with SARS-CoV-2. Well, for one, RSV is a virus that in terms of hospitalization affects mostly very young children. So below 2 years of age, mostly. And this has an impact of how those cases are looked at the hospital level. the level of attention by the healthcare workers with those patients is different. So usually the quality of the data is also different. Okay, so it's not necessarily this. Looking at this, one of the questions that one might ask is, well, is in fact my case definition adequate for SARI associated with the flu or with SARS-CoV-2? It could be that, well, at the hospital level, the healthcare workers are clearly associating with what we want to notify as SARI, and they are simply neglecting the case definition because what they are seeing is what they know that we want to have as SARI cases being notified, regardless whether they adhere to the case definition or not. So this might also indicate that, well, my case definition might be wrong. Again, how do I clear that out? There's no other way. I have to go back to the specific medical record for each individual cases and do a specific study, targeted study, to assess that. Looking only at the notification database is not enough. Well, because, again, I cannot guarantee that all of the information is actually inserted there. But for RSV, so one of the things here, we're going to say, well, it might be the case that for RSV, my case definition is pretty good, pretty accurate, but for the flu and for SARS-CoV-2, not so much. Again, in terms of the data set alone, I cannot answer that, but knowing the details behind what is actually going on and with interviews with, with healthcare workers, it's most likely that it's only a matter of the attention on the notification sheet, okay? And because for RSV, it's young children and healthcare workers take much more care in filling out all the details in the notification sheet. So it's a matter of attention and dedication to the notification form than epidemiology itself. Okay. Now, well, all that being said, in the end, now this is a snapshot of what we had. So the distribution of cases, of SARI cases for different respiratory viruses, stratified by age, for a specific period of 2024. So between epidemiological weeks 10 to 17, here is the stratification looking at the data without applying any symptoms filter. So whatever is in there, only the only filter that is applied is hospitalized or deceased. And here is the information applying the symptoms filter based on the case definition. And we can see that at the qualitative level, it's pretty much the same picture, right? Of course, the magnitude is different because of this, obviously, right? But in terms of what is the virus, first of all, the viral population. So what are the viruses that are affecting, that are being associated with SARI? Pretty much the same thing. What are the most important viruses for each age strata? Also, we have pretty much the same picture. So it's not affecting that particular analysis. So for that, it's not so fundamental to filter out the cases that are not attending my case definition, okay? But this is aggregated data, right? If I look at the actual time series itself, so the black line here is the total, total amount of SARI cases per week. And then the colored lines is the cases with a positive lab result for RSV in light blue, influenza B in yellow, SARS-CoV-2 in orange, influenza A in green, and so on. Again, without applying any symptoms filter, applying symptoms filter. So adhering to the case definition and not necessarily adhering to case definition. Once more, the qualitative picture is pretty much the same, okay? There is a small difference here in terms of the cases associated with SARS-CoV-2 in the population of 50 to 64 years of age. When I applied symptoms filter, it starts to decrease a little bit earlier than if I don't take into account symptoms filter, but this might be only a small fluctuation, and it doesn't affect significantly my situation analysis here. So in general, for this particular analysis, again, not much of a difference, okay? So this, with this, we close this first part of the detailing regarding my what question. Key message here, take-home message here. All that we have said here and the conclusions that we are taking from this comparison, it only applies to this database. There's no guarantee that the same outcome that this particular analysis is not affected by whether I filter out the cases by case definition or not, is the same for other databases associated with different diseases. Okay, this type of analysis I must do for each specific disease or notification system that I want to analyze. I cannot extrapolate and generalize this outcome, okay? Now, next question, the when. Now, when, so is a question of timestamp, right? So, for instance, if I have a data set which is pretty common and easy to come by, which is, one way to infer the number of new cases that are happening in a given place is, to take the difference between the total number of cases of a particular diseases at a given time t and the total number of cases that I had yesterday, right? Or the previous week. At a mathematical standpoint, this is perfectly fine, right? The number of new cases is simply the total that I have today minus the total that I had yesterday or last week. Simple as that. Now the thing is, the total number of cases at a time t in terms of database is the sum of the total cases that I had before plus the number of cases that have been reported at time t. And cases reported at a given time in its own sense is a combination of cases that occurred at that time and have been reported at that time, plus old cases that hadn't been reported before. So total cases at t-1 canceled out, and what I have is, if I simply take this difference, is this combination here, which is not new cases at t, right? Because this is a mixture of what happened today and have been notified, and old cases that have only entered into the database now. So this might not reflect what is actually the current scenario. And again, this depends a lot on how the information flow is being, the characteristics of the information flow itself. So how are those cases being inserted into the database? What is the usual time that people take between identifying a case at the healthcare facility and inserting that information into the database? How this process is taken out? Do I have an online system available at every single healthcare facility that notified this particular case? Is the notification centralized at the municipality health secretariat or the state health secretariat, or it's already decentralized to the healthcare facilities themselves? Are the cases first filled out on a paper sheet and then sent to someone to sit in the front of a computer and digitalize this information? How this process is rolled out? This is all behind the time that it takes between a case being identified and a case being inserted into the database. Of course, the faster this process is, the lower the number of those cases here and the higher the number of those cases over here. So the closer it is, this information is to the actual new cases at t. The longer it takes, then the lower it will be this first number here, which is what I actually want, what is currently going on. Because if it takes a lot of time, what happens this week, I will be only being informed for 4 weeks in the future. So what I see in the data now, it's a snapshot of what happened 4 weeks ago, right? So I move farther and farther away to what I actually want. Now, so it's important, whenever possible, to have an understanding of this whole chain of events associated with the notification process itself, right? So for every given case, I have several time steps associated with information flow. So first I have symptoms onset, right, for diseases that actually have a clinical manifestation. And this is an information that, if the symptoms are clear, is more or less easy to identify. And important, very important, it is as close as I can get to the infection event itself, right? So when the infection has occurred. That particular information that, at least for us modelers, would be ideal, right, when infection actually occurred, this is usually pretty much impossible to assess, especially in terms of respiratory infections. I have no idea, and I usually cannot have any idea on when the infection itself took place, right? Because I don't know the chain of events usually. But symptoms manifestation is a matter of asking the patient, and that's it. Of course, I might have biases over there at that, but this is a process that I can manage somehow. So this I can treat as my event date, right? Because it's as close as I can get to the infection itself. Now, in terms of hospitalized cases, I have, at a later point in time, the hospitalization date, And the hospitalization date is associated with search for care, right? And this is a combination, usually, of two processes. The natural evolution of the disease, right? How long it takes to the symptoms to exacerbate to a level that the individual chooses to go to a healthcare facility. And this second aspect, which is a personal decision to actually go seek and seek medical care. It's a combination of those. So I have natural history and personal decision, okay? And of course, I can also have another ingredient that might impact the individual decision to search for care, which is how far away is a healthcare facility to any given individual, to where this individual lives or where it works, right? This might affect the decision to seek medical care. So this might change from locality, from one place to another. If in a given city I have a ease of access to healthcare facilities, this might help the individuals to choosing to seek care earlier. If access is difficult, individuals might tend to take longer to seek medical care because it's troublesome to actually go to a healthcare facility. So it might be impacted to where cases are occurring, okay? But again, for both hospitalized cases and even mild cases that are attended in an outpatient facility, this is where cases are at least knowable at the healthcare agent's standpoint, right? Because at this point in time, I cannot know that a case has already happened. I will only know that a case has happened once the individual somehow seek medical care. Before that, there's no way they can identify a case. So this must happen in order to access this information here, which is what I want. So I already have intrinsically a barrier between this, to this delay between the event date and the information being available to me, right? But this is one step. Then there is another step, which is the notification itself. Because it's one thing for a patient to be to seek medical attention and so being identified as a case, right, that I want to notify. And then there's another thing, which is for that particular case that now I know that happened, and then filling out a notification form. There's another time delay there. And this is something that I can somehow work out within my system by giving training to healthcare workers, establishing campaigns in order to sensibilize those agents to fill out those notification sheets as soon as possible, and so on and so forth. So there are a lot of things that I can do at the operational side of of surveillance in order to reduce the distance in time between those two events, right? But again, that time here, there's parts, aspects of that I can interfere, but some of them is not directly associated to things that I can do at the political level. And then there's another step, which is, well, it's one thing to fill out for instance, a paper sheet and inserting that into the database. And even for digital notification system, it might there might be a time difference between inserting the data, the notification at the local level, right, in my personal computer at my healthcare facility, and then that information being transferred to the central database. Okay, so how my my communication infrastructure is organized will also have an impact between those two, right? So for instance, in several places in Brazil, for SARI case notification, the notification itself is filled out on a paper sheet at a hospital, and those sheets are then sent to the municipality health secretariat, and at the health secretariat, it's digitalized. Okay, it's inserted into the database. In some places, it's not even at the municipality level; it's at the state level. So it must travel all the way to the capital city of the state before it can be digitalized. Depending on the state, the process of this transportation between the healthcare facility and the central office for digitalization, it can take longer, or it can take a longer time than others. For instance, there are places that the only means of transportation is by boat, and it takes several days to that process alone. And of course, this will have a great impact in this time difference. So again, it's another piece of the puzzle that again might vary a lot from one place to another. So if I manage to have to access what is this delay profile in a given city or in a given state, usually this is not enough for me to infer what is the delay profile in another state, because the underlying characteristics that leads to this delay might differ a lot from one state to another, from one municipality to another, from one country to another. So knowing the delay profile in one place usually is not enough for me to infer what's going on a different place. Okay, so this is a task that I must usually look at the local level. So if my data analysis is run at the state level, I must assess the delay profile at the state level. If I want to stratify my cases by municipality, I should look at the delay at the municipality level, and so on and so forth. Okay? So this is just an infographic to more or less synthesize all of this discussion, right? So if here taken into as an example a vector-borne disease, so the infection is associated to a mosquito bite. Then I have at one point in time I have the infection, and another point in time I have the manifestation of the first symptoms, then visit to a doctor, and database insertion, right? So here it's an illustration of 6 different cases, and so if I am at this point in time, all of those cases, the infection itself has already occurred, but only 2 of those cases I already can identify at the database level, right? At the local level, 4 of those cases is already accessible, okay? But they are not already into the database. So at the central level, the information is not there yet, right? And least of all for those two. This one I could have access if, for instance, I have implemented a self-reporting surveillance system, right? So this is one way to speed up the process of the information flow. At what cost? Data quality. And also, there's another cost associated with self-reporting system, which is the amount of work that I have to put in place in order to mobilize my community to actually notify by themselves whenever they have a symptoms manifestation. This is usually extremely difficult. Okay, there have been several pilot studies to establish self-reporting systems, and usually what happens is that at the beginning I can have a good adherence by the community, but as time goes on, this waters out. And the only thing, one of the ways to try and keep the population mobilized is maintaining active campaign, public campaigns in the media in order to keep the individuals mobilized. And this has a cost, and sometimes a significant cost. Okay, and again, the quality of my data can be somewhat compromised. Okay, now those 4 cases here, now those that have already been attended, so that they are visible already at the healthcare facility, if I am able to speed up the process of information, transference of information from the healthcare facility to my database, I can expedite this information, and then those 4 cases could be already available at that time. So this I can try to minimize this time distance on investing in infrastructure, for instance, and decentralizing the notification, the digitalization process itself. Okay. Now, these 3 graphics here is just to show a little bit an example of how those 2 ways of counting the data, so based on simply when the cases have been inserted into the database, and then just doing the difference into between total counts from 1 week to another, and actually looking at the data based on symptoms onset, how this can impact my analysis. So those 3 graphs here is actual data for COVID-19 in Brazil for 3 different states between 2020 and 2024. The gray line is the time series that is constructed based on database difference. So total accumulated number of cases being simply differed from 1 week to another. Okay, and this is this had been for several years the main way that not only the Ministry of Health but also the media was looking at COVID cases in Brazil. So every state and every municipality, they would send to the Ministry of Health at first on a daily basis, and then later on a weekly basis, the total number of cases that they had at their locality, be it municipality or state. So they would send this total count, And from one day to the other, or from 1 week to the other, what the Ministry of Health will do is simply take the difference between those two data transfers to infer the number of new cases. Okay? And the blue line is the number of cases based on symptoms onset. There's another, so this is one of the differences between the two time series. Another important difference is that for the blue line, the cases come from the dedicated notification system itself. So in Brazil, there's the ESUS Notifica, which is a system that was built specifically for that. And the gray line, so the municipality and the state, they would count the number of cases not only based on the national system, but at whatever form they had to count new cases. So if they had local systems, information system, several places, what they did was to ask for every health facility to, on a daily basis, send to the health secretariat the number of patients that they had on a given day, or at some level of accounting for that. So the origin of the data is different as well, but still. Now, see what happens. I like to highlight a few aspects of those time series. First, here, here, and here. So this is 0, right? And this is minus something. How come I have minus, I don't know, 1,000 cases on a given week? This makes no sense at all. But yeah, this is something that might happen when I am looking at inferring new cases based on this math alone. Because there's another aspect that is not present here, which is data cleaning. Right? Because it's one thing to notify a case, and there's another thing which is to go back at that case and identify, for instance, that that particular case had nothing to do with the disease that I want to notify itself. So I have discarded cases. I have duplicity. Right? I might have several cases that are duplicated in my database, and this I have to clean from time to time. So the cases at any given time t is all of that minus discarded cases and duplicated cases. So whenever the number of insertions in my database is lower than the amount of cases that have been discarded from 1 week to another, I will have less cases, so the total cases at t will be lower than total cases at t minus 1, so the new cases at t will be negative. At the information data flow, this makes perfect sense, and is actually what happened. At the epidemiological level, so what I want to do with the information makes no sense at all. So this is already another trigger that, well, doing that to infer, to assess or infer what is the current epidemiological scenario is not a good idea, because this is something that indeed happened, okay? And then there's another thing. So look at this spike here, this other spike there, over there. There's another spike here. There's another one over here that is not present in the data that is reported, that is looked at based on symptoms onset, but is present on these inferred new cases what is going on here? Any guesses? Exactly. So what happened there was a specific effort to finally insert into the database old data sheets that had been forgotten in a given place, that were left out in a storage room for some reason. And then they built a task force to finally insert all of those cases that have been left out. So now I have a huge spike. This has nothing to do with the epidemiological situation. Right? This is something that happens. And it will, again, depending on how this process of data collection is structured, this type of situation might happen more frequently or not. And I have no idea how it will go on before it actually happens. Okay? And of course, if I have those characteristics in my time series, what happens with, for instance, one analysis that at the modeler standpoint we love to do, which is to estimate what is the effective reproduction number, which is an indicator of whether the number of cases are increasing or decreasing at any given point in time. So if the effective reproductive number is above 1, what it means is that for every new case, I have more than one new cases associated with that index case. So every infected individual is infecting more than one new individual. So for every one case, I'm generating more than one new case. Of course, if this process is happening, if an infected individual is infecting, for instance, on average, two susceptibles, now those two will also infect other two individuals on average. So as time goes by, what is going on? The disease is spreading itself, right? The number of cases is increasing. So the effective reproduction number is pretty much trying to to translate this process here. Right? It's a way to estimate how many new cases are being generated from a single infected individual. So if this number is above 1, the disease is spreading itself. Now, if for every single individual, on average, I infect less than one individual, then, well, I might, simply by chance, it might happen that one case generates two more, but these secondary cases may only infect a single individual. This one didn't infect anyone. So the disease is dying out, right? Because it's not being able to sustain the population of infected individuals, okay? So above 1, I have a spreading process. If it's below 1, the disease is dying out. So this is pretty much extremely important to know, right? Because it's in theory, it's an easy way to infer what is going on, if the cases are increasing or decreasing. Now, if the way that I am counting cases have these kind of pitfalls, what will happen to this analysis? It will be completely thrown out of the window. So this is a comparison of exactly that, an estimate of the effective reproduction number for those two data sets. So in blue, the RT based on the official notification system using symptoms onset as a reference date, and the counts that are inferred by looking at the difference at the total reported cases on a weekly basis. And we can see that there are several moments here in time where I have a complete disagreement between the two. And again, if I'm basing my actions on that, what I'm doing has nothing to do with what is actually going on. So for instance, if I am triggering a public announcement for individuals to, for instance, to use masks, to stay at home, based on that, and in fact, the cases are decreasing when I launch a campaign like that, what happens to the credibility of this process of public alert? Goes to the trash, okay? So, let me see. Now, just to have an idea of what are we actually talking about in terms of those time delays, this is an illustration, again, based on the SARI notification system in Brazil of the time delay between symptoms onset and database entry. Okay, so this is information flow as we were discussing. So you can see that at every single week, usually the percentage of cases that happen on a given week and are reported or inserted into the database at the same week is at most 10%. Okay? So what I'm looking at right now, it's only representative of 10% of what actually had happened, is actually going on right now. So I'm extremely far away from what is going on right now. If I look at the data now, but I go retrospectively and I look to the cases that happened last week, now I have of the order of 45% more or less. So 45%, on average, 45% of the cases are inserted into the database up to 1 week later. Now, to reach the level of at least 80%, I have to wait the order of 4 weeks. This is a month already. So what this is telling me is that right now, what I have in the database here is a good representation only to what happened at least 4 weeks ago. So again, in terms of situation analysis, what this is telling me is that, well, from the information standpoint, I can only, if I take the raw data, my ability to perform scenario assessment or situation analysis is restricted to what happened 4 weeks ago. Today, I can say with good confidence what was going on 4 weeks ago. Right now, I have no idea. this is extremely worrisome, right? In terms of, again, if I want to establish a situation room to perform weekly updates of epidemiological scenario, this points to a dire situation, right? Because what I want to report to the population and what I want to guide my public actions is, of course, should be based on what is going on right now, not what happened a month ago. And again, in terms of the natural history of the disease, I also have a similar picture. For instance, if I look at, for instance, how long it takes for a hospitalized case to be concluded. What do I mean by that? For cases to be checked out of the hospital, so the individual has become cured, right? Or unfortunately, it has died because of the disease. So those two situations we put into under the umbrella of case evolution, whether to cure or to dying. And again, so for SARI in Brazil, we can see that usually most of the cases, after 1 week of hospitalization, it has already evolved either to cure or death. Now, this has an impact. You know, even if my cases were to be notified as soon as an individual is hospitalized, if I want to look at mortality rate or case fatality rate, I still have to wait at least 1 week to have a good comparison. And now this is already limited, of course, to the natural history, how long it takes for a case to clear out, right, to be cured or to die of the disease. And then again, it's one thing for a case to have its evolution, and it's another thing for that evolution to be updated into the database. So again, there's another level of delay here, which is how long it takes for the evolution of the case to be updated into my database. The same happens to lab result and transfer to intensive care facility and so on and so forth. Okay, now and now just now looking at the epidemiological standpoint alone, one thing that is interesting in terms of SARI cases is that this particular picture here, right? So how long it takes for a case to have its conclusion once hospitalized, it's pretty much the same whether individuals have been cured or died of the disease. And here the scale is in terms of days, so it's more or less usually individuals stay hospitalized about the order of 10 days. The median is of the order of 10 days for SARI cases associated with influenza A or RSV, regardless whether those individuals become cured or they die. And for SARS-CoV-2, it's a little bit higher, but not statistically significant. It's even higher, but at the median, it's of the order of about 15 days, so more or less 2 weeks, right? This is important in terms of, for instance, now hospital management, because this has a big impact on hospital beds availability, right? So the amount of time that an individual stays hospitalized is, in the end of the day, the number of days that a specific hospital bed is unavailable for new cases. So the longer it takes, if the number of cases is building up, for how long this will impact my hospital beds availability, it will be completely different. So diseases that are that evolve fast tend to have a lower impact in terms of hospital beds availability than diseases that takes longer to clear out, right? Because for that, even after the number of new cases starts to decrease, the amount of time for this inflection to translate in clearance of hospital beds is directly associated with that, right? Because if they are starting to decline now, this will only reflect in more beds being available 2 weeks in the future, okay? So in terms of how I structure my, my hospital capacity, must take these considerations into account, okay? Now, with this, I finish the first part of the class for this morning. So, so from now we can take a small break. The second part of the class this morning, we will look now into some methods. Now, well, we look now at the some of the underlying aspects of the data. On the second part of the class, we will start looking at, well, even taking into account those particularities. Now, how can we, if we have a way to deal with those issues and construct a time series for a particular disease, how can I construct indicators for situation analysis? For instance, how can I define seasonality? How can I define activity thresholds? So epidemic threshold, medium, high, very high activity thresholds. So indicators to that are extremely important to, again, situation analysis in terms of epidemiological surveillance. Right. So, any questions at this point? Go ahead. Shoot. Good. This is a very good question. So what you are asking, it's associated then, so because at the data analysis level, we are always looking at the database, right? So the first thing is to have a good system in terms of the variables that I have associated with my case notification, right? So if the system that I've put in place do not have a field for instance, lab result, I will never know if those individuals have tested positive or negative to whatever. Okay. The same thing goes for the information here associated with symptoms onset and let's say hospitalization. If that information is important to my analysis, it must be present into my database, and I must establish a guideline that I roll out to every healthcare facility, identified what are the variables that I need filled out for my case notification, okay? Now, and then in terms of lab result, there are two ways to look at that. First is, well, for my particular disease, will it be enough? Will I consider cases based on clinical evaluation alone, which is basically a medical decision, right? It's a clinician decision. It will do the anamnesis. It will inquire the patient on the symptoms that it manifests in itself, other characteristics, and then build up a classification for that particular case. Symptoms only. Then I can restrict my data to lab confirmed cases alone, right? This is another way to look at the data. This decision, it has an impact on, first, the accuracy of my data, of course, right? If I have a positive lab result, this is much more accurate in terms of case classification. But on the other hand, it might take longer for that information to be available, because depending on the test itself, the process of collecting the sample, sending to the lab, running the test, and getting the information back, it might take longer or not. So we have, this is one point that should be here and it's not. There are jargons associated with that. So cases that are identified solely based on symptoms, this is what I call suspect cases. Okay? Suspect cases are those that are classified solely on symptoms manifestation. Okay? Quicker, but less reliable. Okay? The information comes faster at the cost of accuracy. Then we have another level, which is probable cases. Now, the difference between those two, probable cases are still only associated with symptoms. I still do not have a lab result, but I have an additional information, which is epidemiological information. For instance, if for instance, I know that the individual was in contact with persons that had manifested the same symptoms or that have a positive result for that particular pathogen that I'm that I'm looking at. This then becomes a probable case because I have the necessary symptoms, but I also have an epidemiological link to the next step, which is a confirmed case, for instance. Okay. Now, another possibility to have to classify as a probable case is, for instance, if in the locality where that particular case is being reported is already facing an epidemic associated to that particular disease that I'm looking at. So if an epidemic is already in place, then I can move from a suspect case to a probable case, okay? Because I know that there are already several cases going on into my community. So which is very likely, if the symptoms is present, it's very likely that it's actually associated with that particular disease, okay? And finally, we have confirmed cases. And for that, lab result, okay? This is the difference between suspect case, probable cases and confirmed cases. For confirmed cases, I must have a positive lab result. Otherwise, it is at most a probable case, okay? And depending on the situation, it's only a suspect case. Again, which one I will choose for my analysis, it depends. What is the question that I'm asking to my data? This is what will define which of those three I should use into my analysis, okay? How I will filter out my data. For current situation analysis, usually what we do is look at suspect cases because I need quick information. So this is a choice to give up a little bit in terms of accuracy in order to have faster information, okay? I compromise a little bit my accuracy, but at least I can give information faster. Now, if I want to, for instance, define, again, assess risk groups, then ideally I should look only at confirmed cases, right? Because what is the issue here? For suspect cases, I can have both positive and negative cases. And I don't know what is the percentage at any specific point in time, okay? Retrospectively, I can come up with ways to estimate this distribution, okay? But right now, usually I have no idea. So it's a risk to run risk group analysis based on suspect cases because I might be including a significant percentage of cases that are actually not associated to what I want to study itself, okay? So this is why for that particular analysis, we should use only confirmed case alone. I will have less cases, so this might impact my statistical, the quality of my statistical analysis, but at least I have a guarantee that what I'm looking at is actually cases that I want to look at, okay? Good? So let's go to the coffee break, and then later on we come back for the next session. Thank you.